in this video we are going to talk about different types of the equation of a straight line. Or rather different forms for the equation of a straight line. And the one you're most used to using is let's see, this one, y equals kx plus m, where k is the gradient and m is the y-intercept. On the Swedish syllabus, they call this this equation here is called the K-type or K-form equation. However, in the English language mathematics, we sometimes call this the slope-intercept form. Because if we're given the slope, which is the same as the gradient, and the intercept, the m value, then we can express the equation of the straight line completely. However, there are two other types of the equation of the straight line which you should know about, and one is this, which is called the general or standard form. It's written like this: ax plus by plus c equals 0, and these values here, a, b and c, are all constants. And you generally, or normally, the a here has to be positive. The number in front of the x is made positive. But you can switch between these two by just doing some algebra, which we're going to practice in a second. The third type is called the point slope form. In Swedish it's called enpunktsformen. And it's this y minus y1, which is the y-coordinate of a point going through the line, equals k, which is the slope, and then x minus x1. So this is where we have k is the slope, and the line passes through x1, y1. So let's try doing a couple of examples involving these two types here. Let's get our examples from Matematik 5000. So we are going to draw the graph of 6x plus 2y minus 10 equals 0 on on our calculator. So 6x, draw graph of 6x minus plus 2y, minus 10 equals 0 on your calculator. Well, we can't plug in a function like this in our y equals, can we? So we have to rearrange it and get it in the k-type or the slope-intercept form. So how are we going to do that? We have to get y on its own. So we have to rearrange this thing, 6x plus 2y minus 10x equals 0 into the form y equals kx plus m. So we just simply have to do a bit of algebra, a bit of rearranging. So first of all, I want y on its own on the left-hand side. So I want to get rid of this minus 10. Let's add 10 on both sides. So I have 6x plus 2y equals 10. Now I want to subtract 6x from both sides. So I get 2y equals 10 minus 6x. And then I want to divide both sides by 2. The 2's cancel. And if I have to divide both of these terms by 2. I get y equals 10 divided by 2 is 5. And minus 6 divided by 2 is minus 3x. Just swapping these two terms around, I get y equals minus 3x plus 5. So we have converted this, the general form for the equation of the straight line, into the slope-intercept form. And if I get out my calculator, I go to y equals, and I plug in the equation, negative 3x plus 5 trace. And it looks like that. It has a negative slope and it goes through the y-axis at 5. Perfect. Let's try another example. Find the equation of a straight line going through the point minus 3, 2, and which has gradient k equals 4. So we have one point and we have a gradient, therefore we can use the point slope form. So the point slope form of the line, and you'll get this in your formula booklets, is y minus y1 equals kx minus x1, and we were given that k equals, check back the example, k equals 4, and the point has coordinates minus 3, 2, sorry. Minus 3, 2. So I just have to plug minus 3 and 2 into the formula and k, and then I'll rearrange to get the equation of the straight line. So I get y minus y1 is 2 equals k, which is 4, brackets x minus x1, which is minus 3. So I've got a minus 3 here. Let's simplify that. So first we've got y minus 2. We don't do anything with at the moment. then we have 4, and then I have to do what's in the brackets. Minus minus 3 makes plus 3, and then I can multiply in the 4 to get y minus 2, and then 4 times x is 4x, 4 times 3 is plus 12, and then I want y equals, so I just have to add 2 to both sides. I get y equals 4x plus 14. That's the equation of the straight line whose gradient is 4 and goes through the point minus 3, 2. And we'll end this one here. Thank you very much.